Discuss the early meeting to join.
Your mic off.
ये उठी तो देख के बोला ना पूरा कंपड़ा पैरों का दादी में
Itu sama ini buka pagare dan masuk ke sama saus dan sampai menurut kecil tuh di kali dua asih dama nggak ada nggak kena anggar di lalu kita kena bang 2-3 साल लिखो क्या चल रहा है बस और बस में
यहाँ बराबर नहीं आ रहा कैसे ले सकते वहाँ से अच्छा आ रहा वहाँ से चल सकते हैं नहीं सब वहाँ बैठ के भी दे सकते हैं
Good morning.
Good morning, sir.
Good morning to all. We'll be starting the session after 5 minutes. Hello.
Yes, Aziz sir, you can carry on. We are able to hear you.
Thank you, sir.
Galaxy Y6.
Assalamu alaikum. Hello. Good morning.
Good morning, sir.
Within a short while, we are going to begin with this inaugural session. Hello.
So when is the session going to start?
Within 5 minutes, we'll be starting the session.
Continue.
Hello. Hello.
आज एक ही बच्चे आते हैं आप लोग आशा आशा आती ना आशा आती है आशा आते आशा वो खेलते आगे आशा
कुछ लीव करो तुम। Good morning to all. You are requested to stay connected till starting in 5 minutes.
बंद हो गया कटवाना आवाज वीडियो बंद करा मैंने ओ जूम पे तू हाँ जूम पे चली गई यूट्यूब पे मैडम
Hello, Aziz sir. Hello, hello. Assalamu alaikum, Aziz sir.
हेलो
Assalamu alaikum.
वालेकुम सलाम
कैसे सर खैरियत?
हाँ सर we're starting in 5 minutes
Okay, okay, sir. No problem. We are waiting for that.
yes there was some connectivity problem to the other case therefore we are stopped
Okay, sir. Okay, sir. Okay, okay.
Hello, sir. Hello. 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 Anyone is there?
अरे लो एक तो लो.
Bismillahirrahmanirrahim. The chief guest of this inaugural session, Dr. Shamama Parveen, President, Raibar Educational, Cultural and Welfare Society, Dr. A.R. Khan, the keynote speaker, Principal of Sir Syed College, Dr. Sheikh Kabir Ahmed, the galaxy of intellectuals, invited guests, professors, teachers, researchers, and my dear students. A very pleasant good morning to you all present on this inaugural function of this one-day international seminar on Internet of Things technology, IoT, sensor devices, and big data. Let's begin the program with the recitation of Quranic verses. I invite Mr. Asrar Patel, the student of BSc third year, to perform Qirat. Asrar Patel.
أعوذ أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم إن في خلق السماوات والأرض واختلاف الليل والنهار لآيات لأولي الألباب الذين يذكرون الله قياما وقعودا وعلى جنوبهم ويتفكرون في خلق السماوات والأرض ربنا ما خلقت هذا باطلا سبحانك فقنا عذاب النار ربنا إنك من تدخل النار فقد أخزيته ربنا إنك من تدخل النار فقد أخزيته وما للظالمين من أنصار ربنا إننا سمعنا مناديا ينادي للإيمان أن آمنوا بربكم فآمنا ربنا فاغفر لنا ذنوبنا وكفر عنا سيئاتنا وتوفنا مع الأبرار ربنا وآتنا ما وعدتنا على رسلك ولا تخزنا يوم القيامة إنك لا تخلف الميعاد صدق الله العظيم. Indeed, in the creation of heavens and the earth and the alternation of the night and the day are signs for those of understanding, who remember Allah while standing or sitting or on their sides, and give thought to the creation of the heavens and the earth, saying, Our Lord, you did not create these aimlessly, exalted are you. Then protect us from punishment of the fire. Our Lord, indeed, however you admit to the fire, you have disgraced him, and for the wrongdoers there are no helpers. Our Lord, indeed we have heard a caller calling to faith, saying, Believe in your Lord, and we have believed. Our Lord, so forgive us our sins and remove from us our misdeeds and cause us to die with the righteous. Our Lord, and grant us what you promised us through your messenger, and do not disgrace us on the day of resurrection. Indeed, you do not fail in your promise. Jazakallah.
MashaAllah. Reach high, for star lie hidden in your soul. Dream deep, for every dream leads the goal. We are happy to announce that 400 participants from various countries, including Saudi Arabia, Oman, Jordan, Kuwait, UAE, Yemen, Kenya, Sudan, Qatar, and the participants from different states of India, including Uttar Pradesh, Bihar, New Delhi, Tamil Nadu, Kerala, Jammu Kashmir, Karnataka, Telangana, Pondicherry, got their names registered in this international seminar. Today is a special and memorable day that we'll remember in the years ahead. On behalf of Sir Syed College of Arts, Commerce and Science, Aurangabad, Maharashtra, India, I, Dr. Sheikh Muhammad Al-Har, extend cordial welcome to you all. The eminent scholar, the educationist, the loving teacher, and the true leader, late Professor Muhammad Tilawat Ali, is the founder of Sir Syed College. Undoubtedly, Sir Syed College is the outcome of untiring, devoted, and the selfless efforts of Professor Muhammad Tilawat Ali. So, always believed that education is meant for all-round development, and to meet the challenges of the changing world, we have to be with the time and technology. To know more and more about Sir Syed College, I invite the principal of Sir Syed College, Dr. Sheikh Kabir Ahmed.
Bismillahirrahmanirrahim. Respected Chief Guest, the Chairperson, Rehbar Education Cultural Welfare Society, Dr. Shamama Parveen, the keynote speaker, Dr. A.R. Khan sir, teaching and non-teaching teaching staffs and other invitees. Good morning to one and all. Sir Syed College of Arts, Commerce and Science, one of the minority institutions in Aurangabad city. Established in 1990, it is one of the leading institutions engaged in imparting the quality education in the stream of arts, commerce, and science last 3 decades. The devoted and committed teacher known all over Maharashtra for his selfless services, late Professor Muhammad Tilawat Ali, established Sir Syed College that could meet the demand of changing time. Professor Muhammad Tilawat Ali named this college after the legendary Sir Syed Ahmad Khan, an optimistic social reformer and visionary. It is, in fact, the only co-education college in the town that has largest number of girls students. The college is marching ahead under the able guidance of the President, Dr. Shamama Parveen. The ongoing century being the century of youth, the institution is confident and sure that the new dynamic and positive thinking of President Dr. Shamama Parveen will lead the institution from the front and take the institution to appreciable height. The college offers arts, commerce, and science, junior college, undergraduate level, postgraduate courses in Arabic, Urdu, English, and commerce, also chemistry available. To meet the changing economic challenges, the college, after 3 years professional degree courses such as BBA and BCA and BCS, the institution has always taken the initiative to prove its mission, human citizen through education. The college has a long-standing academic tradition and boards of the team of 34 experienced, well-educated, and dedicated faculty with 13 research guides in Arabic, English, commerce, history, chemistry, and botany, zoology. 29 teachers are doctorate and 11 teachers have NET and SET examination. Under NSS, the college is involved under various social activities. Sir Syed College is only college in the region winning intercollegiate football tournament consecutively for 7 years. The faculty is also involved in research work through minor and major research projects. The dedication and the teamwork of teaching and non-teaching staff has won several laurels to the institution. 34 students have stood in the merit list of Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. 3 students received the gold medal in arts and science. Today, approximately 2,000 students are on the campus of Sir Syed College. 2 commerce students of our college have qualified CA examination. 100 of students are regularly placed in various national and multinational companies. 4 students of our junior college got admission in MBBS course in the recently declared result. Sheikh Naushin appeared ninth in the Dr. Babasaheb Ambedkar Marathwada University merit list, and Khan Asma scored the higher marks in zoology, and become eligible for the Mrs. Anita Award. We will all bound to dedication, quality, and excellence. On behalf of Sir Syed College, I welcome all the participants. I hope you would learn more and more about the IoT, sensor, device, and big data. Thank you. Thank you very much, one and all.
Thank you, Dr. Sheikh Kabir Ahmed, sir, for the brief introduction of Sir Syed College. Dear friends, we are quite fortunate to have Dr. Shamama Parveen as the chief guest of this inaugural session. She is the president of Rehbar Educational, Cultural and Welfare Society, which runs Sir Syed College. Following the footsteps of Professor Muhammad Shafali, Dr. Shamama Parveen is leading the institute from the front. We request the dynamic president, Dr. Shamama Parveen, to inaugurate this international e-seminar and address. Dr. Shamama Parveen.
यूट्यूब पे गए ये सर आप पे ये
So,
عشوائيين
Sorry for the inconvenience. Due to some connectivity issues, we are unable to hear Dr. Shamama Parveen. I request the principal of Sir Syed College, Dr. Sheikh Kabir Ahmed, to formally inaugurate this international e-seminar.
हेलो आवाज आ रही है I declared this e-seminar today's international webinar in Sir Syed College.
Thank you, sir, for the formal inauguration. Respected participants, this international seminar on Internet of Things, IoT, technology, sensor devices, and big data is jointly organized by the Department of Computer Science and Department of Physics with some objectives. Internet of Things technology plays an important role not only in communication in computer science, but also in physics, due to the rapid spread of usage of sensor devices. The telemetry of different sense data such as pressure, temperature, illumination, and object detection is one of the potent ways to solve many complex problems by combining with big data. IoT and data mining can also be helpful in solving many issues related to e-health. A lot of applications related to human health and the drastic changes in environment require fast, accurate solutions. Sensor technology in combination with big data can help to solve and improve prediction of disaster and quality of life. The seminar aims to bring together the leading scientists, researchers, and the scholars in the domain of interest from the world. Before we conclude, Before we conclude this inaugural session, I pay my sincere thanks to Dr. Shamama Parveen to grace the occasion. We are thankful to Dr. Sheikh Kabir Ahmed for the inauguration and for his valuable presence. We are grateful to the other dignitaries. This inaugural session is immediately followed by the keynote address by the legendary, the man of ideas, Dr. A.R. Khan. The quote, an idea is better than 1,000 opinions, suits the speaker very well. I now request Dr. Sheikh Asif Karim, Head of Physics Department, Sir Syed College, to introduce the key speaker, to A.R. Khan, and proceed. Thank you.
صباح الخير يا خولاني صباح الخير.
I'm audible. All done. Good morning. Myself, Dr. Sheikh Asif Karim, Head Department of Physics. I welcome one and all present in this session of one-day international seminar on international Internet of Things technology, sensor devices, and big data. The seminar is conducted by Department of Computer Science and Department of Physics at Sir Syed College of Arts, Commerce, and Science, Aurangabad. It is really a delicate balance between making it happen and letting it happen. We all dream to accomplish good tasks and deeds. Only few actually make it. One such a person is with us today. It's my pleasure to introduce the keynote speaker for the day, Dr. Abdul Rauf Khan, for his session. Dr. Abdul Rauf Khan is a well-known personality in the field of science and technology for his multidisciplinary talent in the different field of science. If I go through the detailed information of this contribution to the science and technology, it will take a couple of hours. So I will try to summarize his introduction. Dr. Khan has completed his PG in physics at Dr. Babasaheb Ambedkar Marathwada University, Aurangabad, and continued his research and got his PhD degree awarded under the able guidance of the well-known scientist Dr. Idgi. He has vast experience of teaching at senior college level. He taught 25 years at Kamala Nehru Polytechnic Pharmacy College, Aurangabad, 8 years at Y.B. Chavan College of Pharmacy, Aurangabad. He also worked as the visiting faculty at Government Engineering College, Pharmacy College, Bhagwan Homeopathic College, and at the Department of Physics, Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. He has efficiently led different departments. He has acted as head of PG Department of Computer Science, head of Biotechnology, and head of Bioinformatics at Dr. Rafiq Zakaria Campus, Maulana Azad College, Aurangabad. He has huge experience in research. He contributed 10 years in the field of laser and high voltage pulse power technology, 5 years in the field of fractals and geometry of irregular shapes. He has published number of articles in different research journals. He presented number of research papers at conferences and symposia. He is co-investigator of DBC research project on fractals at Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. His area of interest are laser, quantum electronics, numerical methods, computer science, and interfacing. He was associated with research groups working in different fields. He is life member of Indian Laser Association. He is in charge of computer department at Aurangabad College for Women's, Aurangabad. Prominently and recently, He has bagged 3 patents to his credit. The title of these patents are: first, the vehicle tracking system with real-time reporting. Second one is a non-contact type thermal imaging system. And third one, a system for ionophorosis power supply and data acquisition. So it's really a pleasure to have such an eminent personality with us in this keynote session. I hope we will be benefited with his knowledge. I welcome Dr. Abdul Rauf Khan. Sir, please.
Hello.
Yes, sir.
A very good morning, everybody. Am I able to reach you? Voice?
Yes, sir.
Yes, sir. Sir, you can continue.
So, very good morning, everybody. It is my great pleasure that I am with you all here on the auspicious occasion of the one-day international e-seminar on Internet of Things, technology, sensors, devices, and big data. In fact, today we are surrounded with a large variety of systems and devices, and their control can be implemented using technologies like Internet of Things. And Internet of Things basically relies upon sensor devices that enable the information, whereas the processing of the information involves the use of data management and data analysis and data interpretation. All these things, they basically rely upon big data. So the topic of today's seminar is the need of the hour, and it covers a wide variety of things which are involved in the Internet of Things. आगे क्या वो दिख रहा है तुमको करना था ये वो दिख रहा है यार So the Internet of Things basically makes use of various type of sensors. In fact, sensors are those devices which can feel or experience the surroundings in which those sensors are located. The main role of the Internet of Things today is it enables the operation, control, and monitoring of a wide variety of systems and devices, and it takes the data or the information related to their status, and from there this data is then converted into its equivalent digital form or the form which is intended by the user or the one who has planned the implementation. This user data is then sent to the internet so that this information becomes usable, or it can be accessed by people who are authorized to share this information. And usually the Internet of Things can be considered as a four-layer scenario in which the first layer is made up of a sensor. So the system Can you see the PowerPoint? Hello?
Yes,
Is
sir.
the
Yes, sir.
Yes, sir. Yes, sir.
PowerPoint is visible?
Yes, sir.
Okay, okay, okay. So the IoT is basically made up of these 5 main components: the network of physical objects, which we are calling as things, and the electronics, which is responsible for interconnection of the devices or the device to the rest of the system. And it is done by the electronic circuitry uh, plays around, which may use different protocols depending upon the nature of connectivity that has been utilized. Then comes the software, and it is the responsibility of the software to uh, do the necessary job of connecting several things together. And the data has actually come from the sensor, so it is the very first most step. And the network connectivity takes care of doing the rest of the job of transmitting the data to the appropriate server where it is interpreted and shown. So this is explained in short in the few lines below. Here the word thing is in relation to the variety of devices that are used for monitoring, which may include heart monitor or the environmental monitoring or the food process monitoring or any other sort of things. So all these things which are to be measured, they are presently we are calling as things, which may be the temperature of the atmosphere, it can be humidity, it can be anything around, which is under our observation and which can be physically measured. In fact, the history of IoT is a bit typical. People call it to be initiated at around 1999, but there are other views also, because as it gradually kept on changing from time to time, the technology had a variety of phases. It makes use of different types of sensors. How does this IoT technology work can be explained in short through this slide. It makes use of techniques which have capability of communication, addressability, identification, sensing, actuation, and embedded information processing. This actually means there has to be a sensing element which can sense the process we actually want to monitor or control, and this sensor gives the necessary information regarding the status of the ongoing process. And many times, if the example is so simple that there is an overhead tank which is being filled by an automatic pump, a sensor will sense the water level. If the water level exceeds some value, an action will be initiated so that the pump can be switched on or off depending upon whether the tank is full or not. So such remote operation can be done through the use of IoT. The IoT can be viewed as a grand network consisting of smaller networks and computers connected through a series of intermediate technologies where numerous technologies like RFIDs, wireless connections may act as enablers of this connectivity. That means the connectivity could be provided by such thing, or the information could be made available by these things. And in this process, the tagging of the things, that means if we have several devices which we are calling as thing, each device can be tagged or can be given an ID, and such thing is possible with the help of RFIDs, but there are various ways in which you can provide different tagging and feeling things. This means the operation we want to monitor, or the system you want to observe, or the device you want to know about is called as thing over here, and to feel is to know more about it. So sensors act as primary devices to collect the data from the environment or the process or the system or the device to which those sensors are coupled or attached. This third point, which lists shrinking things, it means these days there is a trend of reducing the size of the system which is performing the IoT affair. So miniaturization of these electronic components is referred to as the shrinking of the things. Shrinking things. Now, the point is this information which has been collected can be intellectually processed to draw conclusions of your interest and take actions with the help of suitable actuators. The current scenario of IoT in terms of connected devices is shown here in this figure. Interestingly, this is one of the very popular graphic, which is has become an indispensable part of all the presentations and deliberations. So this simply shows what was the status of the world population, and it is compared with the number of connected devices. So here years are given, 203 up to 10, 15 and 20. In the year 203, there were only 0.08 devices connected per person. That means if there are 10 persons, there are only 0.8 devices, like less than one device. And the numerical values are also shown here, world population and connected devices. And here it is increasing gradually to the right. And this is the point where the number of devices has become equal to the number of connections. That means what is the population? For each individual head, there was at least one connected device. So this is the point. And thereafter it has exceeded. Today the status is for each individual, there are approximately 6 to 7 internet connected devices. Just it shows the popularity, relevance and importance of the internet connectivity, which actually leads to things like IoT of things. So these days it is catching up and it is very popular. And this grandness of the activity, this ratio actually generates more data. So it becomes extremely difficult to handle and manipulate this huge amount of data. And because of this huge amount of data, new tricks and techniques are to be evolved, which will be discussed under the head of big data. So this is also one of the things which is responsible for generating big amount of data. IoT as a network of networks. This diagram just shows different areas in which the IoT is being used extensively: transport, education, home, earth, energy, and at the center of all is business, other myths or other simple heads which need not be listed as individual but are listed under the head of others. This earth stands for the situation where you monitor the position using GPS system, where your global position in terms of longitude, latitude and elevation is shown by the GPS units. So this whole connectivity generates huge amounts of data, which is really tremendous. Now we were talking of the 4-layer model of the IoT. So in this, the first most layer is sensing and identification. So at the main operation level, there are different types of sensors which come in contact with the system you want to observe, watch, or monitor, such as this is a ultrasonic sensor, this is GPS and RFID. So this is the first layer where you have sensors, and these sensors, they are responsible for acquiring the information and data of your interest from the surroundings or from the place where they are connected to. And this information is then sent to the internet. This is shown by network connectivity or network construction. There are a variety of networks shown over here. The data that is acquired from the sensors is now sent to the network, and from the network, it is sent for processing to processor, where the information is analyzed and useful information is extracted out of it, and decisions will be taken. And this decision making is done at integrated application. These applications take data and information from different resources and ultimately implement what needs to be done, and that action is taken, and that is also a part of this. So it includes actuators also. The application of IoT in healthcare is shown here as a few things. It provides real-time data, makes devices smarter, and you can implement some analytics. And application of IoT in agriculture. These days, agriculture is also making extensive use of the IoT technology, because in the big farm management, there are sprays and nozzles and jets of water where you have to provide necessary irrigation at the farm location. So to do this, there are sensors available which sense the temperature, humidity, and moisture. And based upon the information coming from different location on a given field, they use their actuators to open the valves, to start the jets, or to control water content in the soil, or they can spray mist to control the humidity at the selected location where there is deficiency. Similarly, it is in the industry also, you know that automation is a must, and at every step they are going for automation, which reduces the complexity of the process in addition to the saving the manpower. So this is that. And to explain in a simple format, here it is shown that what are the three components. As we are now discussing for quite some time, these are the main three things which are connected. This is the sensors, the connectivity, and people and processes. And these are three spheres, and the overlap of all these things is shown as IoT. It is just to simply present the information. How is the IoT helpful? This is a simple slide. You can just go through it, and in the meantime, I may have a glass of water. So there is nothing very much different from what all we are talking about, but it is just graphically showing that the connectivity has been established in different things which can be employed successfully and usefully by gathering the information from those and making use of it. Another slide showing similar pattern, that how the internet connectivity and the Internet of Things could be used for a wide variety of disciplines which are very much important from our day-to-day life. This shows one segment, the smart city, the other segment of smart hospital, the next one for the smart highway, for smart factory. This smart city, smart hospital, smart highway, smart factory, or even smart home, it has become a trend to call things as smart if there is a provision for lot of automation. For example, in my house, if there is a smart home facility built in, then it will be possible for me to switch on my AC from anywhere sitting in my office. I can switch my AC or switch the fridge, or I can switch lights, or I can exercise control on the electrical commodities at home, sitting at some place in the office or on the bus, in the train or a remote place. So like that, these smart places means they are equipped with IoT equipped systems which can be manipulated from anywhere where you have access to internet. This is a graphic which is showing the pace at which the Internet of Things is growing in the present time, and challenges faced by the IoT are given here: scalability, security, technical requirement, technological standardization, software complexity. So these are a few things. I think the voice from Sir Syed College is overlapping, so something could be done for that if easily possible. So coming back to where we were, I was telling that these features are the challenges. And for example, scalability. If I ask somebody, give me a piece of paper from that table, he will just pull the paper and give it to me. But if I say, give me 1 million papers from that table, then to lift that huge lot of those things, he has to adopt some new method other than the one he has just used just now. So similarly, security, technical requirements, and all these things, they pose various type of difficulties when you plan to implement a grand successful IoT system. So at the core of the whole show, there are sensors which are responsible for deriving or obtaining information. So here, sensor is a device that measures physical inputs and converts it into data that can be interpreted by either a human or a machine. Most sensors are electronic. The data is converted into electronic data, but some are more simple, such as a glass thermometer, which presents visual data. So the sensors can be two types: one which is giving you data in the electronic form, another one, this is giving you the data in the analog form. So the IoT relies upon the use of data which is in the electronic form. Sensors in IoT. IoT is the platform wherein recent times it stands for all the technology related things connected using internet. The function of IoT is to deliver multiple types of information and intelligence through use of various kinds of sensors. These sensors operate together and gather the information, they process it, and this is shared across multiple connected devices, making the technology smarter. And commonly used sensors are here: temperature sensors, which senses the temperatures of the surroundings or the surrounding in which the sensor is placed; IR sensor. IR sensor is infrared sensor which can detect the presence of infrared radiation, or it can measure the amount of infrared radiation that is incident upon the sensor. The ultrasonic sensor senses the sound whose frequency is beyond the audible range. So this is a sort of sound sensor of sound waves at frequencies higher than the normal audible frequencies. Touch sensor, which senses whether something is touched or not. Proximity sensor, which is a type of sensor based upon various techniques, which senses the presence of an object, nearby object, and based upon what technology it is used, its capabilities may differ. And there are pressure sensors which sense pressure. Level sensor is the sensor which is used for sensing the level. Smoke and gas sensors are also used. And there is one more sensor, very important one, which is GPS, the global positioning sensor. The sensor senses the real-time global position in terms of longitude, latitude, and altitude of the place where the sensor has been placed. Typical sensors or detectors are just shown here to give you a feel of how do they look like. The temperature sensor is LM35 or similar one. It has 3 legs. It is a small thing, maybe less than 5 millimeter in the size. This is a IR transmitter and receiver pair for use in the proximity or line tracking system. So this is a small module in which there are 2 LEDs, light emitting diodes. One is acting like a source, the other acts like a detector. When the infrared radiation is sent by the transmitter, after it reflects, it comes back to the detector, and when the detector receives the reflected infrared ray, it actuates and tells you that something is present within the prescribed range. The sensitivity can be set over here. This is a ultrasonic. While discussing this, I think I used the word of ultrasonic. If so, this is based upon infrared rays, and infrared rays are emitted by the detector and they are received by the sensor, and this detector ultimately sends the information to the processor, where it is found that whether there is some object in the vicinity or not. This is a similar thing which does not send the infrared rays, but it sends ultrasonic sound, so that the ultrasonic sound after reflection comes back to the detector. This T stands for transmitter. This transmits ultrasonic sound, and it reflects from somewhere if there is an obstacle in front of it, and reflects back to the detector, and detector will detect the reflected part. Here is the receiver. So depending upon how much time is spent between the transmission and reception, the distance of the object can be determined. So it can also be used for finding out distance of an object that is placed in front of this transmitter receiver pair of the ultrasonic. There are other sensors to presence the vicinity of something nearby, and when the object comes close to this, it will actuate the signal and further processing will do. And in the proximity sensor, there are various type of capacitive sensors are there, inductive sensors are there, photoelectric sensors are also there, IR based sensor we have just discussed, ultrasonic sensor we just discussed. There are more type of proximity sensors which are extensively used in the industry to automate the process and to connect to the Internet of Things, to monitor the real-time status of a ongoing operation in the factory with the help of internet connectivity. And here is the touch sensor. When you touch it with the finger, it will generate a signal over here to tell that it is touched. There are some chemical sensors also where the sensor is placed right on the electronic chip itself. And the other sensors include sensors of carbon monoxide, hydrogen, methane, alcohol sensor, etc. Air quality sensor are also available as a standard, and this is MQ2 smoke gas, LPG, butane, hydrogen gas sensor. Non-dispersive infrared gas detectors. Somebody is drawing nice graphics over here. I am thankful to the one who is adding fun to what is going on. Yeah, thank you again. Oh, infrared gas detectors. So this infrared gas detectors look like this. This is a very advanced type of detector or sensor where infrared radiation is generated from the source. When it passes through a gas, its properties get slightly modified, and knowing that difference, the situation can be understood as to what is the nature of the gas, what type of properties it possesses, so that the sensor is more reliable. Humidity sensor. This is the humidity sensor, and the sensor is attached to a module over here, and this is sensor module. And if the humidity of soil is to be understood, here is it. So I think these graphics are indicating me that I should wind up in short. So we quickly have a brief look at the big data. Thank you very much. Yes. Now please highlight the second point and just read it for me. This is the next slide I wanted to show about the big data. And you graphic master, please add. Okay. Thank you. Now underline next one, please. Please. Next one. Okay, if you don't, I will proceed to the next slide. Go through this. This is the big data scenario, how it is creating. Yes, you have marked the wrong thing now. Okay. Wrong thing again. These are the characteristics of big data which are considered to be important. The first one is the volume of the data, which is in fact the quantity and the amount of data that is at hand. And the next thing is the velocity. Velocity stands for speed. The speed at which you are able to collect the data, store the data, or process the data. These are the three places where the speed of the data matters. And it becomes important to have a judicious control. Second one, thank you. Velocity at which the data is processed is the crucial most part. And another thing that is the main hurdle in the fast growth of the big data is the variety of the data. As the variety of data keeps on changing, the issues of handling manipulation becomes more critical. Few characteristics of big data, the 3 points, they are just narrated over here in quantitative terms. It is as a typical example, Boeing 737 will generate 240 terabytes of flight data during a single flight. It is tremendous amount of data, and storing such data and analyzing, processing poses challenges. The second character of the big data is the velocity, that is the speed at which you need to handle or manipulate the information in order to extract useful conclusions from which necessary actions can be initiated to exercise a control. If this big data is in relation to a IoT scenario, the result of the processing of the data will enable the effective implementation of the corrective measures based upon the data status. Third character is the big data of the big data is the variety. Big data is not just numbers, dates, and strings. Big data is also geospatial data, 3D data, audio and video, and unstructured text, including log files and social media. So this is a big canvas where the data has a wide, big span of varieties, and accommodating all such data in one single system and usefully utilizing it becomes one of the challenges as we discussed. Big data analysis includes different types of data. This is the third point. Big data is generated by users, applications, systems, and sensors. And large data is responsible for the growth of files. I think this is sufficient information related to the big data, the IoT, and sensors. And this is some information which is readable, but I don't know, very strange. These lines are popping in. Somebody is either interested in this, or maybe it is, I don't understand. Somehow, this is now a new information for me to be processed, understood, and interpreted. Anyway, this is last but one slide. So we go to the next slide. As you must have just thoroughly gone through. This is just to give you an overview of what is happening in the field of big data and the areas in which the big data analytics is applicable is just shown over here. And that brings me to the last point of what I wanted to share with you all people in the grand seminar. And with that, with that, I think we have some time where we can have a question answer session if the organizers feel like.
Yes, sir. Yes, sir.
And if the
yes, sir. Thank you, sir, for the detailed and informative talk. We are really surprised by the information you have shared of the drastic growth in internet connected devices and its increasing trend. Now the session is open for the discussion. If anyone is having any question, please feel free to ask from the participant side. Any question? Please feel free. The questions are welcome.
Yes, please feel free to discuss any point. Yes. If I have the proper answer, I will let you know. Or if it is not within my reach, I will inform that also. And if it is important to share later on, we will do that also.
Sir, one question is there from YouTube viewer.
Yes.
It is about the ultrasonic and infrared. It is asked that in comparison with ultrasonic and infrared sensors, which one is more efficient, economic, and faster?
You see, frankly speaking, Both the sensors are very cheap. In terms of Indian rupee, they are not more than 100 or 200 rupees. And what is important is the velocity of light is 3 into 10 to the power of 10 centimeters per second. That means it is very fast. So if one is measuring long distances of the order of kilometers, and if he has having facility to measure time duration up to a fraction of a microsecond, then for such applications, infrared or visible light will also serve his purpose. But for the purpose of measurement of small distances, suppose 2 centimeter, 5 centimeter, 10 centimeter, for measurement of such distances up to 2-3 meters, ultrasonic proves to be ideal, and ultrasonic sensor also cheap, and you can measure distances of few centimeters with the help of ultrasonic sensor. If somebody is interested, there are many.
Any question now? Any question? No. So thank you, sir, for responding to the entire satisfaction of the participant. We are grateful to you for giving interesting as well as informative talk. We learn a lot from this talk. Thank you very much once again. Now, the keynote address is immediately followed by another talk. I request Dr. Fahim to proceed.
There was a question, but okay.
Yes, sir. You can continue, sir. Yes, sir. Please, sir. Answer.
There was one question from some Tawassum or some such name. But it went from the scene. I don't remember it precisely. If that question is sent again, I would be able to appropriate.
So the question, or I will just say the question. Can you throw a big light on conservative storage or data handling technique for data generated from the sensor? Data generated from the sensor. How to store it?
Census?
Yes. So the data for sensor.
Yes. Data storage from the sensors is also one issue related to big data. But I tell you, this data from sensors is not a big data scenario. Big data scenario refers to such data which was used for DNA analysis type of things, where it used to take 10 years with the normal computing approaches, which has become easier to come down to about 1 week in the today's scenario. So this is how the big data is the bigness magnitude. Otherwise, census data is okay. That is also approaching the big data scenario. And that storage, etc., it does not pose problems, because hundreds of terabyte storage is no big deal these days. Okay. And there was another question about wireless sensor. I could not quickly see what exactly was asked. Any more questions? What was this question about? Anyway, we take it as that I missed that question, and I apologize for not being able to attend to that question quickly. So I express thanks to everybody for giving me a patience listening, and also to the one who has underlined the useful stuff and at times change the canvas. So very much thank you for the organizers for giving me a chance to address the gathering of the intellectuals. Thank you very much, everybody. So I take your leave.
Yeah, hello.
Yes, please. Hello. Sir, I mute my mic now. I finished my part.
We have our next speaker, Dr. Muhammad Arif. So, very good afternoon, everybody. I myself, Dr. Sheikh Fahim, Assistant Professor in Department of Computer Science, Samsiyat College, Aurangabad. So, our next speaker is Mr. Dr. Arif, sir. So, before inviting him, let me give his brief introduction. Dr. Muhammad Arif Abdul Rashid has been serving as assistant professor in the Department of MIS College of Commerce and Business Administration, Dhofar University, Oman since 2007. His master's in computer science followed by PhD. He has over 20 years of experience in teaching, quality assurance, and other academic and curricular activities. Dr. Arif has published about 30 research articles and papers in various national and international journals. He also attended and participated in about 25 workshops and seminars and conferences too. He also served in Department of Information Technology, Salalah College of Technology, Oman. He worked for University National Accreditation and International Accreditation process at Dhofar University, Oman. Further, he also delivered guest lectures as subject expert in several academic institutions. Dr. Arif is the member of Dhofar University Quality Assurance Committee since 2013. He is serving as controller of examination there. He also worked as a member of University Research Board. With this brief introduction, I would like to invite Dr. Muhammad Arif, who is going to speak on the topic Internet of Things.
Yeah, thank you so much for inviting in this particular workshop. Here we are going to, inshallah, learn about some IoT basics. Moreover, in previous session, we already have gone through the overall view of IoT. I'd like to thank the management of Samsiyat College and organizing committee of this particular valuable event. I'm also grateful to all attendees who are with us today. Let's begin our journey. Here we can have now we'll be having a short introduction about our topic. We'll focus on socio-technical mapping, need for IoT. We'll see what exactly IoT is, and we'll see some live example on the industrial side, and we'll try to focus on the future scope. The role of ICT, that is information communication technology, is significantly increasing in our everyday lives, and it has a predominant influence on the development of economy and information society. The positive impact across various economic sectors in the interdisciplinary application is only possible with the growth of these technologies. Hence, ICT need to be used prominently for the development of innovative products and services in order to address societal, market, and business challenges. In today's technological world, the large number of interconnected devices are executing under the umbrella of IoT. With this technological development, IoT opens an era creating new services that could bring significant changes to the society, individual, of course. IoT play an imperative role in various domains, such as smart cities, smart transportation, smart logistics, smart industry, smart meter, smart grid, and so on. The socio-technical mapping. The Internet of Things is promising topic of technical, societal, and economic significance. It has the potential to significantly drive business, technology, and economic growth over the next decades. The IoT is connection among several entities, also called things. These entities or these objects or these things become the part of our life that communicate intelligently with one another to execute daily operations. We'll see need of IoT. Before IoT, what was the situation, and after IoT, what exactly the scenario? So we still have a devices to do things for us before IoT existence. What is the difference between with or without IoT? The difference is that we need to run from one machine to another machine. The difference is that we need to run from one machine to another machine to telling them what to do for you. This is about before IoT. But using Internet of Things, the devices can be But using Internet of Things, the devices can interact, collaborate, and learn from each other experiences just like we humans do. The ultimately goal is to reduce intervention of machine cycle. So what exactly the need? What exactly the goal? To reduce the intervention in the machine cycle. The machines are here continuous in touch with each other and could be pre-introduced what to do and when to do. These machines can be adapted to the need and can modify according to the need of human being. What exactly IoT? Here, two parts are there, Internet and we can say as the things or objects. Internet is a network of networks we all know very well, and it is the medium through which the devices interact, collaborate, and exchange the data. On Internet, one device can communicate with another device. Sometimes people understand wrongly that the web is Internet. World Wide Web or WWW is only the way to access and share information that is available on the Internet space, whereas the Internet is a huge network. That connects various devices globally. Any device can communicate with other device as long as they are connected to the Internet. So what are the objects or what are the things? Things is an entity or an object with intelligence connected to the Internet. Object is embedded with software or electronics. These objects can connect it with computers, laptops, mobile phones, etc. So IoT is a platform where everyday services are connected to the internet and they can interact or exchange the data with each other. So somebody is still playing with that, with the screen.
Can you hear me?
Anyway, we'll continue.
Sir, just clear. Sir,
Please
just clear from the
reset the file, PPT file. Reset the PPT file.
Okay, sir. Just give me a second.
Sir, this screen share.
Hello. Hello.
Is okay?
Sir,
is okay
from
now?
the top there is an option of clear skill is coming.
Yeah, it's okay now.
Yes,
It's
okay,
okay
sir.
now.
You can continue.
It's okay now, sir. You can continue, sir.
Okay.
Arif sir, please continue.
Okay, fine. Thank you so much. Yeah. So here on the screen, you can see that the A's refers to the globalization of the technology. That is anytime, anywhere, any device, any network. The C's reflects the properties of IoT, such as collections, convergence, connectivity, and computing. However, today's IoT is already reached beyond the range of A's and C's which are available on our screen. If we see the IoT have different perspectives and different views from different angles. The perspectives of services provided by things, perspective of connectivity, perspective of communication, perspective of networking, and overall. So perspective of services provided by things, that is a world where things can automatically communicate to computers and each other, providing services to the benefits of humankind. And perspective of the connectivity, it is for anyone from any time, anywhere, that is connectivity for anything. The perspective of communication, it is a worldwide network and interconnected objects uniquely addressable based on standard communication protocols. The perspective of a networking, it is an internet evolved from a network of interconnected computers to a network of interconnected objects. So overall, it refers to the business process and the application of sensed data, information, and content generated from interconnected world by means of connected devices that exist in internet infrastructure. Here we can see various domains which are available to improve the operational efficiency and interaction with the people. Adoption of IoT technology is in various domains like everyday lives, healthcare, smart cities, agriculture, industrial automation, disaster management. In a previous session, we already gone through some of the best examples ever, and we have got very useful knowledge about what kind of applications in different domain. Now, on right-hand side of our screen, these domains are classified in this pattern. So smart cities, industrial services, health sector. So smart cities further divided as smart homes, smart mobility, smart utilities, and public services. Industrial services consist of logistic, agriculture, and some industrial processes. Today, we'll see one example about industrial process. For health sector, medical care, and independent living. Consider a home appliance, such as AC. Currently, what we do, we go home, turn on the AC, and wait for the temperature we like. This is perfectly functional setting, but it could be a better. What if the car is 5 minutes away from your home and the AC receive a message? What if it connect to the cloud, had a dashboard containing all the relative information like a location of the car, the outside temperature, and the temperature that we like to our room. The AC could turn on before we arrive in the home and create ambience that we could like. So this is one domestic example through which we could understand. And the IoT could play an important role in improving our comfort of life. Everyday life is not restricted till the home appliances, but also it includes these supports to make better life of a human being. So these are different variety. Just now in the detail already we had learned in the previous session. This is what IoT building blocks. So n number of physical devices interconnected in IoT network, we all know very well. Using recent computing technology, such as edge computing, which include the sensors, controllers, actuators, tag readers, communication components, gateway, and the physical devices. We do have some other computing that is also fog computing, which is the extension of a cloud computing. And the roof computing. It is real-time outside operations facilities. So here what happens, somebody was asking the question, what about the data storage? So the data stores in different zones. On the industrial, as an example, in the industry, just now we'll see the example, where the operation, whatever the sensors are, whenever the sensors, they produce some data, those sensors, they produce the data, and those data, first of all, it stores in the local memory area. Then it shares to the submaster area, and it goes to the master station. So these are nothing but three categories where the data storage and the control system work. So internet acts as a communication media of various dispersed physical entities. The interacting physical devices in IoT equipped with device-specific embedded software, sensors, and network supporting components. We all know about this. The sensors realize the presence of physical entity using device-specific embedded software in the surrounding and gather the information required for interaction. The information can be collected from physical devices, and then the collected information processed using storage servers on the web. Further, can be delivered to actuators in right time to be utilized by different applications. Here one example is there. On your screen you can see the example, the industrial example, which is SCADA, that is supervisory, control and data acquisition. The SCADA, here one example is given from the waste treatment plant, how the data is accumulated on one place, which is called as master station. On the top, which on your screen, on the top of your screen you can see, this one is the master screen. This is the actual plan which exists, and this is the complete working module where the SCADA system let you know, monitor and control various remote functions and processes by using serial communication link between master and remote stations. What exactly mean by remote station? Remote stations are very far away from the master station. Master station is nothing but a collection of a few computers, few big screens, and these are the interacting screens are there. And through these screens shows the status of the remote station. What is the remote station? It is on site, maybe few kilometers, maybe few hundred kilometers possible. The industry or the processes of the industry which is going on, and the sensors, they read the data, they calculate the data, and they send those data through a wireless medium. And these, to handle all these wireless media, they have to establish a network system, a robust network system. And this robust network system, after establishing of these robust network system, each sensors need to be checked one by one. The process is called as, in some industry it is called as a COM, that is COM. In some industry it is called as a OCM. In some industry it is called as MOC, depend on the type of operation. What is COM? That is, they used to control, C for control, O for observe, M for measure. So the sensors measure the data, and the observation takes place in the master station, and they used to measure, and according to the observation they used to control the processes within the industry. Industry is a complex integration of so many functions at the same time, and the network infrastructure is basically provide the media to transmit the data from one point to another point, whereas all these different sensors, which we'll see one by one with some schematic diagrams, and these sensors, they transmit the data. Usually these sensors, they can generate the data. They generate the data either they generate a digital data or analog data, depend on type of the sensors, and accordingly those data need to be transmit to the station or the substation or the master station. Here one example of use of remote point. Let's say on the industry side, we need to monitor and record the physical properties of the oil flowing through the pipeline. So some specific sensors and the devices which are attached, and here with that one, with the same sensors, they have some kind of processor, as already we have shown, we have seen in a previous session, that with the sensor they used to have some kind of processor, and these processor along with the memory, the local memory, which can store the data after reading from the processor. The processor collect all the data and put in the memory, and accordingly, as per the need, as per the program written in the processor, the data transmit through these, whatever the network media which is supported online, and these sends the data to the station, substation or the master station, depend on the connectivity, depend on the privilege. One more thing is that usually it happen in the industry that the substation usually they don't communicate to each other. They don't communicate to each other, whereas they communicate to each other via master station only. But some special case, it could be possible that the substation can communicate to each other. So gas station, another example, this is the automatically retrieve to or store parts within a factory by using radio or power line modem. Here what we have, here this is the substation as an example, and the gas station is very far away from the control room. Control room may be very, a few kilometers away from the gas station, and whatever the exactly sensors are reading the information, they transmit via air media, and those again process and store according to the need of the demand. Here we have one more example, which is related to monitoring and controlling a city's fresh water supply. Here from the top view you can see, here we do have some, these are the different sites which are nothing but the collector wells from where the water need to be collected, the booster station, then the reservoir where they and the water plants. So all these data from the sensors need to be collected and sent from far away to the main master station. So city water plan, here in the same way what we have seen, this is the same remote station, different remote station, and these remote station, they send the information or they provide the information of their plant to the main or the master station. Now what is there in the master station? You can see in the master station, all the readings, all the data used to appear in the form of charts and very well graphics. Now here one kind of a question might be there. Somebody was asking this question also, how to validate those data? Whatever the data is coming from the sensors, whether those data are correct or not correct. How to validate that one? So at the time of design, they used to have a testing phase. In the testing phase, what they used to do, they provide different values, they input different values to the sensors, and with the same one they used to observe on the workstation whether these values are coming, the same values are appearing on their screen on the master station or not. Let's see one example. Let's take the example of a water tank. So water tank need to be, the water tank is connected with a some motor. So motor is operating and taking out the water from the particular tank. What happens during these motor operations? One time it happens that the water tank becomes an empty. An empty water tank may destroy a particular motor. In this case, what happens actually, the sensors, they used to monitor continuously what is the level of the tank. So in this case, what they do, they at the time of testing, they put a 25% of the water in the tank. They fill 25%. At the same time, they used to check whether the tank level, which is physically is there, the same level is showing there or not. So each and every sensors, each and every reading on each and every possible ways, they used to test at the beginning, at the time of installation. So these are the things. Maintaining those things itself, it is a big challenge, and some expert engineers, they used to put their needs to follow up all these things in continuous way. So this is the schematic presentation or representation of smart cities. So in this figure, the city is equipped with a various end devices such as network of sensors, cameras, smart meters, screen, speakers, and thermostats, etc., that collect the information. The amount of information collected from different sources are referred to as open data, public or private data, or we can say a big data, depending on the availability of their source. A common management platform, a city operation, will be responsible for managing, analyzing, sorting, processing, and forwarding the information where needed within the city to improve the services according to the citizen needs. The horizontal management layer ensure coordination, interoperability, and optimization of the individual services or application. The authorities or citizen can access the services offered by different platforms using their applications, can consume them, and can actively participate by creating additional content that will be further analyzed to properly manage the city. A logical infrastructure provided by such technologies controls and coordinates the physical infrastructure in order to adapt the city services to the actual citizen need. So this is what smart cities, basically it is focused on the need of the citizens. It is based on the need of the citizen while making the city more sustainable in all terms. Here, these are the feature scopes. Okay. As we categorize whole, IoT in three, main domains, that is smart cities. One of them is smart cities. If somebody want to do some kind of research, if somebody want to, make their career, so still we have plenty of space so many countries, they are developing their infrastructure in using IoT technology. And everywhere there are so much demand on different sectors to design them, to install them, to maintain them. Remember one thing, to maintain such infrastructure also requires a huge expertise people, a huge number of expertise people who could able to who could able to maintain them in a better way. So home security system, video surveillance, then access management, children protection, entertainment, comfortable living. This is all about smart homes. Smart mobility related with intelligent transport system, traffic management system like bike, car or van sharing system, multimodal transport, road condition monitoring, parking system, connected and automated driving, automated adaptive traffic control, payment system, tour guide services, and so on. The utilities with the individual or home or to the citizen, that is nothing but smart grid. Nowadays, we are getting all power supply. That is nothing but a one-way at our home, only one wire is connected through that one, the one cable is connected. Through the cable, we are receiving the power. But the grid or the, the company who is running these power station, they don't know how much consumption we required. So this is nothing but now the normal grid is converting into a master grid, which consists of bidirectional data, where the home also can able to send the requirement using what exactly and how much exactly the power is required for a particular home. As a whole, for the whole city, the total requirement of the power supply can be counted and can be measured and controlled. So this is what in many countries these implementation is going on, and many of the countries, they already implemented these type of thing. So there is a huge number of chances of employment as well as in the research. In some of the cities where no adoption is there, still the gap is there. So the missing gap can be completed by the researchers, as well as the employees could able to get a proper job in a particular stream. So public services and safety environment. So public services, including emergency rescue, personal tracking, video, radar, satellite, and of course, environmental and territory monitoring. Next one is industrial processing. Just now we have seen one of the example, and that was one of the best example. Most of the companies, they are using this particular SCADA system. So smart manufacturing, which is there in the logistic and product lifetime management, identification of material, product, goods, or product deterioration, and we can have a warehouse, retail and inventory management, shopping operations and fast payment, agriculture. Just now we have seen some of the controllers already, how it can be there, how it can be used in different domains. So medical care, this is also one of the important focus area which need to be work on using IoT. So medical equipment tracking, secure and access indoor environment management, smart hospital services, environment services, remote monitoring of medical parameters and diagnostic. And independent living, some of the countries, they believe on all these things, and this is what this is the total overall presentation. So hope if you have any question, anything, so please. The time was given to me. I try to complete in the time, hope so. So thank you so much, everyone who was with me, who listened. Yeah, from my side, it's okay. I can't hear you. I think Fahim sir is not audible.
Anyone having any questions? They can ask. The session is open. Hello. The session is open.
Hello.
Hello. Hello. Any question? Any question from the audience?
If you have any question, please unmute your mic.
Any question from the audience?
So thank you so much, sir, for giving this opportunity.
Yeah, thank you, sir.
So I conclude from my side. Yeah.
I think there are no queries from participants. So let us assume that there are no queries.
Sir, I have a question, if you may allow that, please.
Yeah, please.
This is Mujtaba Momin, and thank you very much. It's so nice to see Arif sir again after such a long time. So how are you doing? I hope you're doing well.
Yeah.
Sir, what I really loved about this talk is you simplified these concepts to such an extent that it was very easy for someone who's not even from the field to understand it so well. Thank you very much for this informative session. What I always feel curious about is this. How do you think this IoT will be democratized? You know, how will it reach the masses? Because at this point of time, we see that the costs are really high. There are no integration protocols for different devices and manufacturers. What do you see as the way ahead in terms of democratizing IoT and in terms of, bringing in a uniform authority or a regulator which will perhaps take care of the synchronization issues in the future?
Yeah, very good question.
Yeah, obviously, this is a very important question related to the implementation point of view. You are absolutely right. Actually, as of now, there are two parts. If we talk about, if your question will be before COVID, my answer may be something different. But now after COVID, we do have, most of the countries, actually, most of the businesses are suffering from financial deficits. And nowadays, I can't say any kind of, let's say, a better future. But as the growth of the industry and the development and the demands of the people and the the requirement of the government itself, hopefully, the IoT could have a better future. Now, another part is whenever the technology is there, in the technology, always remember, we know very well, in any organization, they adopt the technology when they are financially, very strong. This is one part. If the organization is not financially strong, definitely they don't go for any kind of technological development. So as of now, in condition post effect of COVID, we all know very well, everywhere the situation is too tidy in terms of financial issues. Hope so. These financial issues will be solved definitely in the democratic way. Hopefully, the countries are going to be adopt this one, and almost many of the countries already adopted these kind of thing. Whatever I have shown you, this is already implemented, plans which I shown you in various countries. It is already being used. So thank you so much for asking such kind of important question.
So any other queries, please?
Thank you, sir.
You can unmute your mic and ask the queries if you have any. So let's assume that there are no more queries from participants. So thank you very much, Dr. Arif sir. You have given very much important and useful information on the emerging technology IoT. You have explained very well with its building blocks and its various applications. We also learned the working of SCADA system today. You have explained this technology very well with the help of example of gas station, city water plant, and how it is applicable in smart cities. So it was a valuable information you have given, sir. And definitely, sir, this information will be useful and beneficial to all of us. I would like to thank Dr. Arif, sir, Thank you very much, sir, for accepting our invitation and joining us today. Thank you, sir.
Thank you. Thank you so much.
So friends, this is the end of our first session, that is morning session. And as per our schedule, now we have lunch time from 1 p.m. to 2 p.m. as per IST, Indian Standard Time. So here we will have a break from 1 p.m. to 2 p.m. Okay. After a break, we will continue our second session, in which we have some more speakers who are going to speak on various technologies. As we have Jack Kahiko from Kenya. We have Mr. Fahad Abdullah from Jeddah, Saudi Arabia. He will discuss sensor devices. And Mr. Murtuza Junaid Faruqi from Oman will give you information on big data technology. So this is the time to have a break now. There is an announcement for all the participants. All of you have to join the second session at 2 p.m. sharp with the same link which has been provided you in the morning session. So let's meet at 2 p.m. and we will continue with our second session with our rest of the speakers. Thank you very much.
Thank you very much. Be sharp at 2 p.m. IST. For this session, we are very accurate about the timing and all. For the next session also, we have to follow all of the same thing. Once again, thank you to all. Reminder that the same link has to be used for connecting the session after lunch.